Hey guys, Mr. B here. In this video, we're going to be going through the practice problems in chapter 14.3 on mechanical advantage and efficiency. So, beginning here with number 1, it says, why is the actual mechanical advantage of a machine always less than its ideal mechanical advantage? So remember that whenever we are doing something with a machine, friction is always going to be present. So the actual mechanical advantage of a machine has to take into account that there is friction, and the ideal mechanical advantage basically ignores friction. So you're always going to have less actual mechanical advantage because friction is always present. Okay, so we can say the actual mechanical advantage will be less than ideal mechanical advantage because friction is always present. Okay, we're going to make this font a little bit smaller too, so that way we don't run out of space so much. There we go. Okay, and we'll zoom in here maybe a little bit more. Let's do, okay, maybe not that far. Whatever. All right, that's fine. Anyway, okay. Number 2, you test a machine and you find that it exerts a force of 5 newtons. For each 1 newton of force you exert operating the machine, what is the actual mechanical advantage of the machine? Okay, so our equation for actual mechanical advantage, if you go back in our notes, is output force. So the machine force divided by input force, which is your force. So in this problem, the machine's force is 5 newtons. So this is our output force. And the 1 newton is our input force. That's how much force we are putting in. Okay. And mechanical advantage, again, actual mechanical advantage is output force divided by input force. So to calculate this, we will say that AMA, or actual mechanical advantage, is equal to 5 newtons divided by 1 newton. So 5 newtons divided by 1 newton, we will get an actual mechanical advantage of 5. And by the way, you'll notice that our mechanical advantage doesn't have any units on it because it's not a number with units. It's actually just a factor of. So like basically it's just saying this machine will increase your force by a factor of 5. Okay, it's multiplying by 5, but there's no units on it. So there you go, 5. That's it. All right, number 3, why can no machine be 100% efficient? All right, I feel like we're just repeating ourselves over and over again when we say this, but remember, there's always going to be friction present. So no matter how well a machine is built, it will never be 100% efficient because you're always going to lose some amount of work due to friction. Okay, so we can say that no machine will ever be 100% efficient because you will always lose some amount of work to friction. Okay. All right. Number 4, what information would you use to calculate the efficiency of a machine? All right. So if we go back and look at our notes, our efficiency is calculated by taking our work output, or the work that the machine does, divided by our work input, which is the work that we do, times 100. So what information would we use to calculate the efficiency of a machine? We would need to use the output work done by the machine and the input work done by us. Okay, those are the 2 things that we will need in order to calculate efficiency. All right, number 5, it says, suppose you are an inventor in 1900. You are constructing a bicycle of your own design. What could you do to ensure your bicycle efficiently changes the work input into forward motion? So basically this question is saying, like, what could you do to make sure that your bike is the most efficient possible? And there are some things that we mentioned at the end of the notes here that can reduce friction, such as ball bearings, lubricants, minimizing air resistance. So basically, we're just going to say all those things. So we can say we can make sure that we use good ball bearings. We lubricate the chains and other things on our bicycle, and we also make it as aerodynamic as possible. Okay, we can say to reduce air resistance. So all of those things will essentially make our bicycle more efficient. We're going to duplicate this slide too, and we're going to erase this so that way we have question 6 and it's not sliding off of our slide here. All right, question 6, it says, you have just designed a machine that uses 1,000 joules of work from a motor for every 800 joules of useful work the machine supplies. What is the efficiency of your machine? All right, so again, efficiency. And if you look back at our notes, let's just make sure we have our equation. It is output work, so the work done by the machine divided by the amount of work you do, and then times by 100. Okay, so in this case, we have designed a machine that uses 1,000 joules of work from a motor for every 800 joules of useful work the machine applies. So our efficiency is going to be equal to, in this case, 800 joules. So this is our work output. Okay, that's the amount of work that the machine is supplying, which it says here that 800 joules is the useful work the machine applies. And we are going to divide that by 1,000 joules, which is how much work that we have to use to do it, and then times, there we go, times 100%. So let's just do this on a calculator. I'm pretty sure it's 80%, but we will make sure that we get this right. So 800 divided by 1,000 times 100, we get an efficiency of 80%. Okay, so 80% efficient, which isn't bad. So, all right, last question, number 7. If a machine has an efficiency of 40% and you do 1,000 joules of work on the machine, what will be the work output of the machine? Okay, so if it has an efficiency of 40%, okay, so if it has an efficiency equal to 40%, that means if you do 1,000 joules of work, it's only going to give you 40% out. So what we're going to do is we're going to take 1,000 joules, multiply by 40%, but we're going to multiply it as a decimal. So rather than 40% as a decimal, this is going to be 0.40. Okay, that's how you take 40% and turn it into a decimal. So 1,000 times 0.40, this will give us 400 joules of output work. Okay, so we put in 1,000, the machine only gives us out 400 because it's only 40% efficient. So, all right, guys, that is the last problem for these practice problems. Hopefully, again, that helps clear up any confusion and shows you how to calculate mechanical advantage and efficiency. But as always, if you have any questions, make sure you reach out and ask. All right, that's it for this one. I'm Mr. B. Thanks for watching, and I'll see you in the next one. Bye.